Recursion is a process of function calling itself to perform a specific task. The function would repeatedly call itself until it satisfies a base condition. Look at the syntax here. I have a function rec underscore function, and it has few lines of code that needs to be executed when this function is called. So when I call this function, it would go to the function definition and start executing this code. This function is calling itself at some point of time. So it goes back to the definition again and starts executing the code again. Now it calls the function again, and this would repeat until it satisfies the base condition. The best example to understand recursion is finding the factorial of a number. Factorial of 0 is 1, factorial of 1 is 1, factorial of 2 is 2 multiplied by 1, which can be written as 2 multiplied by 1 factorial. The factorial of number 3 is 3 multiplied by 2 multiplied by 1. 2 multiplied by 1 can be written as 2 factorial. The same is the case with 4 factorial, it's 4 multiplied by 3 factorial. To generalize, if we have a number n, the factorial of number n would be n multiplied by n minus 1 factorial. Let's try to reverse this. If I have a number 4, the factorial of number 4 is 4 multiplied by the factorial of a previous number, which is 3 factorial. In the next step, 3 factorial should be evaluated to 3 multiplied by 2 factorial. In the next step, we would evaluate 2 factorial, which is 2 multiplied by 1 factorial. And in the next step, it would be 1 multiplied by 0 factorial. We can consider 0 or 1 as our base conditions because we don't have to repeat the function again. Let's see how we can implement this using recursion. I'll define a function, factorial. This receives a number as argument. I'll call it n. So how do we find the factorial? By multiplying the number with the factorial of the previous number, which is n minus 1. Calculating the factorial of previous number is nothing but calling this function with a number less than this number. When should we stop calling this function? If the number is 0 or number is 1. In such case, we'll return 1. Otherwise, we'll return the number multiplied by factorial. Let's try to understand how this function works. I'll pass the argument 4. What happens is n will be substituted with the value 4. It's not equal to 0 or it's not equal to 1. So it will return 4 multiplied by factorial of 3. Now it calls this function again. The value of n will be 3. It's not equal to 0 or 1. So it will return 3 multiplied by factorial of 2. Again, n will be substituted with the value 2. It's not equal to this, it's not equal to 0 or 1. So this if block will be ignored. It will return 2 multiplied by factorial of 1. Now the value of n is 1. So this condition is satisfied. It will simply return 1. So this function will be now substituted with the value 1. Now 2 multiplied by 1 is 2. That will be returned and the value will be substituted here. 3 multiplied by 2 is 6. That will be substituted in the previous function call. Now coming to the final function call, this would return 24. So the actual function would return the value 24. Let's try to print this. And look at the output. We see 24 in the output. Always make sure you provide a base condition, otherwise it would lead to infinite recursion.